In this video, we're going to start to talk about heap performance optimization. When you write a heap program and run it on the GPU, you probably want to optimize the performance. But the performance doesn't come on its own. We have to tune our program to reach the highest performance. So starting from this video, we're going to teach you a series of methods that can optimize the performance of your heap program. Before we teach you any concrete method, we want to do some analysis. We want to list the GPU resources and consider where the performance bottleneck can happen. In theory, every component in your GPU can be the performance bottleneck. So let's list all of them and try to reason about all possible performance bottlenecks. At the beginning, we have command processor. Command processor is the gateway between the CPU and GPU. It is also responsible for dispatching the blocks of a kernel to the compute unit. Therefore, here we have the block dispatcher as a resource. Then we have compute unit. A compute unit may have some resources in its own, can execute a certain number of wavefronts. And as we talked in section 5, a compute unit typically has 40 wavefront slots, a certain number of registers, scalar registers, and vector registers, and also the local data share storage space. If we're running out of this space, the compute unit cannot execute more wavefronts at the same time. And also another very important resource that determines the overall performance of the GPU is the number of computing ALUs. So if we have a lot of computation that needs to be completed, these computation tasks will occupy the ALUs and take a very long time to finish. And if we keep looking down, we have caches. The interface between the compute unit and the caches is related to memory coalescing. It's about the number of transactions that we need to send from the compute unit to the caches. Now, if we send a lot of transactions, the bandwidth between the caches and the compute unit may be a limiting resources. And the caches themselves can be a performance bottleneck as their spaces are limited and their bandwidths are also limited. And finally, we have DRAMs. The DRAM have limited amount of bandwidth, so if we want to load a lot of data, the memory bandwidth is a limiting factor. So in the rest of the video, we're going to focus on every component and consider in what case this component can be a performance bottleneck and how we can mitigate the performance bottleneck. We're going to organize the heap performance videos in two units. In the first unit, we'll focus on the front end of the GPU, the command processor, and the compute unit. In the second section, we're going to focus on the back end of the GPU, including the caches, the DRAMs, and the memory system as a whole.